Yes. No. It's just identify the asymptotes, the horizontal and the vertical asymptotes. Not graph. And that's it. Ready for our lesson for today? Awesome. Okay. Now we are going to need graphing paper, guys. So you guys have graphing paper? You guys want some? Okay, go ahead and give me guys some graphing paper, and I had it right here. Scissors and glue too? Everything else? The whole thing? Let me pass it. It's going to be to graph complex rational equations. Now we're going to go ahead and go easy at this first. We're going to go ahead and look at some not complex, but like some simple complex rational functions first. Okay, so we're going to go ahead and go step by step. So we're going to go ahead and go out the first step of the complex rational functions. Let me go ahead and put it like that. Okay, so let's go ahead and first refresh our memories. We have our vertical and our horizontal asymptotes. And we have now our steps to graph complex rational functions. So here we go. Our first one is to use long division to rewrite the rational function. So we're going to go ahead and bring it back. Second step is to identify then our vertical and our horizontal asymptotes. Third step is to build an input-output table, very similar to our domain, but yet different. We're going to go ahead and build a different type of domain this time. And the fourth step is to graph the function. Okay, go ahead and write these down so you can have them in your notes. Rational functions are going to be displayed. They're going to be similar yet different. So let's go ahead and just revise first our simple type of rational functions. So here's this example number 1. We're going to go ahead and just review it very quickly, but I'm going to go ahead and go over a different type of method on how to graph it on the beautiful graph here. I broke my scissors. Okay. All right. So we have g of x equals 1 over x plus 2 minus 3. So in this case, we're going to go ahead and first identify our beautiful asymptotes. I'm going to go ahead and identify my horizontal asymptote first. My horizontal asymptote in this case is y equals -3. My vertical asymptote is x equals -2. Very similar. Actually, is the same example that we had in our warm-up. I made it so you guys can already identify them, so we can go ahead and graph them. So here's my horizontal asymptote is at -3. So we're going to go ahead and graph it. -3. All the way through. Now my vertical asymptote is at -2. X equals -2. So here it is. All the way down, all the way down. Very beautiful. Now we're going to go ahead and do the table. But this time we're going to go ahead and do a different type of table. Instead of choosing -2 with the domain of -2 all the way to +2, we're going to go ahead and choose a table where we only have 2 values. Our x and our g of x. We're going to go ahead and choose one value that is on the right of our vertical asymptote and another value that is on the left of our vertical asymptote. So my vertical asymptote here is at -2, right? Which one's the value that's to the right? -1. And the value that's to the left? -3. So we're going to go ahead and purposely select those 2. So let's go ahead and figure out what the values are. So let's see, we have g of -1 equals 1 over -1 plus 2 minus 3. I have -1 plus 2. Beautiful +1. So it's 1 over 1 minus 3. -2. So this is going to give me -2. So -1, -2 right here. Now I'm going to go ahead and do the same now for g of -3 equals 1 over -3 plus 2 minus 3. -3 plus 2. -4. Are you sure? -3. It turns into -1. Oh, I was going step by step. I thought you told me that denominator is negative 4. I was like, no. Oh, okay, negative 1 minus 3. This gives me negative 1 minus 3, which gives me negative 4. There you go. So let's go ahead and graph it at negative 3, negative 4. Right here. Now, since we know that all the values as they approach the vertical asymptote are going to approximate it but never touch it, we're going to graph the rest of the values very, very, very close to that asymptote, but never touch. The same goes with my horizontal asymptote. We know that they're going to go ahead and come and be very, very, very close, but never, ever, ever touch that horizontal asymptote. These 2 points, guys, it tells us where they're located and which of the, let's go ahead and say quote unquote quadrants. But they tell us that they're going to be located in this quadrant, this quadrant, this quadrant, this quadrant, this quadrant, this quadrant, or these 2 quadrants. So it's going to go ahead and basically tell us where they're located. Once we find out where they're located, we can go ahead and draw our Hertz graphs. We're going to go ahead and follow like that. So let's go ahead and do the bottom one. Yes.
Why was it? Why did you choose -3?
So I looked at my beautiful vertical asymptote right here. The vertical asymptote is x equals -2, right? So I'm going to go ahead and look for a value that's to the right of it and a value that's to the left of it. So I can go ahead and see where those 2 points located. Once I have those 2 points, I can go ahead and see where they're located on my asymptote and then figure out if they're going to be above or below my horizontal asymptote. Yes. You can go ahead and do the same as those, but we're just shifting them. So I was wanting you guys to shift them.
I got that.
Okay.
I don't know about that.
Okay. Oh yeah, we're supposed to, yeah. Once we get there, we can go ahead and find what the other values. These 2 points are going to tell us where they're located on the 4 quadrants. Okay, now we got this. All right, so let's go ahead and now go over to the next step. Let me go ahead and say, everybody has this. Awesome, okay. All right, so next example, example number 2, g of x equals 3x minus 4 over x minus 1. Now that we practice, we're going to go ahead and now step it up. This time we have a complex rational function. We're going to go ahead and do our first steps. Our first step is to rewrite our beautiful rational function so we can go ahead and identify with the purpose to identify our horizontal and our vertical asymptotes. In this case, yes, we can go ahead and look at the denominator. Yes, we can go ahead and look at or find what the vertical asymptote, but we need to find what that horizontal asymptote is. So we need to rewrite this in a little bit. So I'm going to go ahead and write it in long division. Do you guys remember long division? Okay, so this is my divisor. This is my dividend. I have 3x minus 4. And we have outside x minus 1. Now, I'm going to go ahead and see what value do I need to multiply this entire expression outside so it can go ahead and equal this expression inside, or at least the leading coefficient to it. So what do I need to do? What do I need to multiply this leading coefficient of x so it can be equal to 3x? What do I need to multiply? By 3. So I'm going to go ahead and multiply by 3. Let me go ahead and delete my beautiful. So therefore, I'm going to go ahead and write minus. Inside parentheses, 3 times x is 3x. 3 times -1 is -3. I'm going to go ahead and distribute that beautiful negative sign. So I have now -3 plus 3. So -3x plus 3x, sorry, 3. And let's go ahead and simplify. So we have -3x minus 3x, this goes to 0. -4 plus 3 gives me -1. So now the way that I'm going to rewrite this beautiful equation or this beautiful function is g of x equals my whole number is 3. My leftover, my remainder is -1, and it's being divided by x minus 1. Does it look kind of familiar?
Yeah.
Not yet? Okay, let's go ahead and make it a little, let's do one more step so we can make it more familiar to our eyes. G of x equals, instead of writing 3 first, I'm gonna go ahead and write -1 over x minus 1 plus 3. Does that look familiar now? Yes, it looks more familiar to our eyes now. Now we can go ahead and identify the asymptotes, and we can go ahead and make our little table and then graph our beautiful rational function. So let's see my beautiful vertical asymptote and a horizontal asymptote. Let's go ahead and start with horizontal. Y equals +3 vertical. X equals +1. So let's go ahead and graph those values. So x equals +1. So right here, all the way down. And we have horizontal at +3. Okay, so we have our asymptotes. Now we need to see where it's located, either here, 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 or here. So let's go ahead and do that. Let's go ahead and create our beautiful table. Am I going too fast? No, okay. So let's create our table. Here's my table. Now we're only going to choose two values. Here's x, here's g of x. Here's my vertical asymptote, which is the first one that I'm going to choose. To the right, 2. And to the left, 0. All right.
So you choose the right first or?
Either or, you're still going to graph the point. So I like going right first and then left, or left first and then right, whichever way you decide.
On the vertical, that's it. It's on the vertical.
Yes, on the vertical asymptote.
And it doesn't matter like where, but on the vertical?
That's where we're gonna see where we're on the x-axis. We're on the x-axis first, vertical asymptote 2 and 0, and then we're on the y-axis if they're going to fall.
No, but like I'm saying, it doesn't matter. So like you could choose 3 and -2. And so basically
3 and -2, yes, it would still give me the same, but it will still give me values that are very far away from it, very, very close to my asymptote, but I just want them as close as possible to that number, where that little curve goes.
4 and 4.
4 and 4. Let's go ahead and see. G of x of 2, -1 over, let's see, 2 minus 1 plus 3. This should give me -1. We have -1 over +1, which is -1 plus 3, which is +4.
Oh. No, is it -1?
-1.
Oh,
2 minus 1 is 1. So we have -1 over 1, which gives me -1 plus 3. Oh, 2. Thank you, 2. There you go. Goodness gracious, I was thinking of that. Next one, we have G of 0. We have -1 over 0 minus 1. This is going to give me +1. Plus 3, this gives me 4. Perfect, okay.
The first one I saw it.
So we have 2 right here, and we have 0, 4 right here. All right, now that we have the points, now we know where they're located and which of the little quadrants are located. We are having them in this little quadrant over here and this quadrant over here. And we can go ahead and graph them approaching the asymptote, approaching the other asymptote, approaching my vertical asymptote, and approaching my horizontal asymptote, but never, ever touching it. It just approaches it as much as possible. Not too bad, huh? Okay, one more. Let's go ahead and practice one more, and then I'll give you guys the activity. Go ahead and see. Ready? Okay. Okay. Let me go ahead and here. All right, so go ahead and copy this one down. G of x, 4x minus 7 over negative 2x plus 4. Okay. So here's our table. Here's our function. Go ahead and copy this down. All right, so let's go ahead and do our long division first. We go ahead and do it in black so you guys can see it. What goes inside of my beautiful little house here, my division house? Close, inside. There you go, 4x minus 7. Outside my divider, negative 2x plus 4. All right, so let's go ahead and look at the leading coefficients here, or the leading terms. I have negative 2x and 4x. What do I have to multiply negative 2x to make it into a positive 4x? Negative 2. So I need to multiply by negative 2. All right, so let's go ahead and do our beautiful work here. Let's go ahead and continue to write negative inside parentheses. Negative 2 times negative 2, positive 4x. Negative 2 times positive 4, negative 8. Now, don't forget about the subtraction of this negative sign. We're going to go ahead and make it into a positive, minus, positive. So we have 4x minus 4x goes to 0. Negative 7 plus 8 gives me 1. So my beautiful function should look like this. G of x equals, my whole number is negative 2. My remainder is 1, so plus 1. And my divider is negative 2x plus 4. All right, now let's go ahead and rewrite it. G of x equals 1 over negative 2x plus 4 minus 2. Now can we identify our beautiful horizontal and vertical asymptotes?
Yes.
Yes. Okay, so yes.
No.
My whole number goes first. So, okay, so let's say, okay, let me go ahead and bring another example. So let's say that it's 25 divided by 4. How many times does 4 fit into 25? 6, right? So subtract 24. We have 1 remainder, right? So it's 6, and we have to add the remainder, which is 1, and it's divided by 4. So that's why we write the whole number first, right here. The remainder divided by the divisor. Does it make sense like that? Okay. So whole number is what is on top. Our whole number is on top. Our remainder divided by our divisor. I deleted that part. Let me go back. Okay, so let's go ahead and now identify our beautiful vertical and horizontal asymptote. So horizontal asymptote is at y equals negative 2. And our beautiful vertical asymptote is it at 2? Negative 2x plus 4. Yeah, it's at 2. This would give me 0. X equals positive 2. Okay, all right. So let's go ahead and graph them. Positive 2 right here. This is at negative 2, so right here. So we have to the right, we have negative 1, and to the left, we have negative 3. Okay, let's go ahead and create our beautiful table.
Wait, x equals 2.
Oh, yes. Sorry, guys. Sorry. Let me go ahead and fix that. Oh, I have my asymptotes different colors. I want to make sure I color code everything.
Oh, it's this.
Vertical asymptote is that +2. Sorry. And I graph them incorrectly too.
Oh, wait, so I did. Oh, I did get it. Damn, right. No, I didn't.
Let me see. Horizontal asymptote at -2, so down here. Goodness
Oh, I
gracious.
did. Yeah.
There you go. Thank you guys. I'm having a case of the Mondays on Tuesday. There you go. So there you go. What's my right value? 3 and 1.
1.5.
X and G of X. So for 3, we have 1 over G of 3. 2, -2 times 3 plus 4. -2, so -1/2 minus 2. -2.5 or 2.5. It's that for 1? It's probably for 1. For 3? Yeah, because you get -1/2 minus 2. So you have 1 -1/2 and you're adding another 2 negatives to it. So it's -2.5. Okay, let me go ahead and make some space for my next value. We have G of 1 equals 1 over -2 times 1 plus beautiful 4. We have -2 plus 4, which is +1/2. +1/2 minus 2.
-2.
-1/2. -1/2. There you go. So let's go ahead and graph these. At 3, it's -2.5. So right here. At 1, it's -1.5. So right here. So now we see that they're on these two, basically not quadrants, but those two sides of the asymptote. So grab our beautiful function and we make it as close as possible to our asymptotes as we can. Okay. You ready for the exit ticket? All right. Let me go ahead and save. And let me go ahead and clear. Unclear? Go back. There you go. I'll go ahead and show you guys that the exit ticket in a bit. So here's your exit ticket. G of X equals 5x minus 7 over x minus 2. Go ahead and try it out.